Hello, everyone. Good afternoon. I hope all of you are doing well. Welcome to the Kubernetes Bangalore June 2020. Uh, just give me a minute. Yeah. So I welcome you all to the Kubernetes networking meetup of June 2020. Today we have with us Vinod and Piyush. So Piyush works at DigitalOcean and Vinod he works at VMware. So they'll be we'll be having discussions with them on the topic of Kubernetes networking. So without much ado, I'll be handing it off to Piyush. Piyush will be introducing us to the Kubernetes networking. How is it done? What are what are the components that are at play? So I over to you, Piyush.
Yeah, thanks, Prakash. I hope I am audible. Yeah, let's get started. Okay, so hello everyone. I am Piyush, and I would be talking about introduction to Kubernetes networking. Just a bit of introduction about me before we go into the Kubernetes networking part. Uh, I am a senior developer advocate at DigitalOcean. I started my career by joining IBM as a software developer. I worked there for more than 5 years, and I was mostly involved with developing developing tools based on cloud native technologies like Docker, Kubernetes, etc. I also serve community as part of Kubernetes SIG contribacks. I'm also an APEC coordinator there. You can find me on Kubernetes Slack. My handle there is Pensu91. You can reach out to me on Twitter as well, the same handle. And or if you are the kind of person who would rather write an email, right? So please feel free to reach out to me at pgupta@distillation.com. Now, moving on. Right. So this is going to be the agenda for today. We will talk about how containers communicate in a Kubernetes world, then how pods are communicating to each other. We'll take a look into what are services, what is kube-proxy, what it does, and what is an ingress, and how it helps you out. Right? And there's going to be a bonus in the end of the presentation, so you'll have to be on standby or listen to the whole thing to get to the bonus part. Moving on. Right. So, okay. So Kubernetes in itself is it is a pretty complicated tool, right? They have got a lot of components, and those components are talking to each other. There's a lot of chatter going on. There are a lot of communications happening, right? And this diagram, by the way, doesn't cover the whole thing, right? It is just a representation of things. There are much more components here, right? You have got your control plane components talking to each other, then they are talking to your worker components using kubelet, and then you have got your pods talking to each other, you have got containers inside pods that are talking to each other. So there are a lot of things going on, right? The thing that I want to cover during the course of this presentation is to create a foundation on how some of the basic communication happens, and then that can actually serve as a baseline for further components, right? So, one of the first thing. I'm sure if you have been working with Kubernetes, you would know the unit of deployment or the basic atom in a Kubernetes world is called a pod, right? And pod is nothing, just a group of containers, right? So you can think of it as an enclosure where you would be running your containers inside, right? And a pod necessarily doesn't have to run one container, right? The way Kubernetes is evolving, the way use cases are evolving, the way we have got service mesh kind of workloads, right? There are a lot of other things happening just other than our application container running inside the pod, right? You have got your multiple sidecars, you have got the networking helpers like a POS container, those kind of things, right? Now, how do these containers talk to each other, right? And that is one of the very basic components, right? You have got your containers. Pods are ensured that they would be running on one node all the time, right? So there is not going to be any internode kind of communication. So you can be sure that these two containers are going to be running only on one node, right? So one of the very basic way to communicate between two containers is using a shared volume, right? So Kubernetes has a concept of volumes where you can mount them at a specific path inside your container, and from there you can basically write something to that volume, and then the other container can read from there, right? It's as basic as it gets, right? I hope this is visible to everybody, right? And I will just walk you through that. This is just basically an implementation of the previous concept that we saw. Like, so this YML basically creates a pod, and that pod has got two containers. One is an Nginx container, and one is a Debian container. This example is, by the way, very widely used to demonstrate this concept, right? So you have got so if you just see in there, I've got a volume that's called shared data, right? And I've got two containers. One is an Nginx container, one is a Debian container. And in the Nginx container, I just mount that volume at user share Nginx HTML, right? And if you see from the Debian container, uh, that particular volume is mounted inside a path called pod data, and I just run a command to echo something into the index.html file, right? So if you have been using Nginx container, or if you are not using it, there is a default index.html file that comes, welcome to Nginx and all those kind of things. So what we are essentially doing is we are overwriting that file from the Debian container, and when we run the Nginx container, we should be able to see that okay, this file has been modified, right? So what I'm going to do is I'm just going to go to my terminal, and I will just show you that how does that look. Okay, I hope you can see my screen. Okay, so I will just, so I've got a Kubernetes cluster. It's got 3 nodes. Should be coming up just now. Awesome, right? Now, this is my YML, right? The one that I was discussing about. It has got the pod. Its name is two containers. Got two containers. One is an Nginx one. One is one is the Debian container, and volume is known as one. So what I'm going to do is I'm just going to run kubectl and cd0 YML. So I'm just going to do this demo live. I hope Mr. Murphy is not hanging around here somewhere. Kubectl get pods. Okay, so we are on container creating. So our Debian container is just going to run and vanish away because it's not going to do much. Okay, I guess people are not able to share the screen. Oh, sorry, really sorry about that. Okay, so I will just repeat what I was doing till now. I've got, okay, I will just go back. So basically, I've got a Kubernetes cluster, right, with 3 nodes, and I've got this YML with me. It has got two containers, right? It's the same YML that we were discussing in the previous slide, right? One is an Nginx container, one is a Debian container, and I'm just mounting a volume that's named shared data, right? And basically, this is being mounted from the host, right? And I did a kubectl create, and it created a pod for me, two containers. Now, one of the container, that's the uh, Debian one, it's just gonna write the file and it's gonna die, right? So I should have the Nginx container running, and if you see 1 by 2, it's not because something errored, it's just because the Debian container. Uh, I will just clean. I will just. Yes, yes. I just saw that. Uh, I hope that's better. Okay, let's see. Right. So as I mentioned, right, I have got the two containers pod running, right, and one of the container that was the Debian container. It has rewritten the index.html on my on the shared volume, and my another container, that's the Nginx container, it should take those changes, right? So what I'm gonna do is I'm just gonna exec into the Nginx container, and I'm just gonna see that that happened or not. Right? So that's the path basically where the index HTML is stored, right? And if you see here, the response is from the Debian container. Now that's the response that we had put in from our Debian container. Sorry. As if you see here, that's the response that we were trying to feed from the Debian container. So this is just a basic way how a container can talk to each other, but of course this is not the only way. I'll just go back to the slides now. Perfect. I guess the slides are visible now. Right. Now, another way of doing a container-to-container communication is via using localhost, right? So all the pod has its own namespace, right? And all the containers see that exact same namespace there, right? So if I take the example of what I was just talking about, having an Nginx container and a Debian container. So container one can run an Nginx application, and then container two can just do a curl on let's say port 80 or whatever else, whatever port your application is exporting, right? So from a container point of view, the local host is still limited to the pod's namespace boundary. Right? So if you want to fetch some information from a container that's present in the same pod, right? You don't need to do anything, right? You just need to do a curl on the local host and the port that your application is serving. Right? Another way, right, that I have not mentioned here is they are also all the containers are also part of the same process namespace, right? So you can also do an IPC, right, or inter-process communication. Right? That would be a little complicated to make that happen, but yeah, that can also be one of the ways, right? Now let's try to level it up, right? So container to container communication is good. We have got multiple ways, pretty basic things to do. But Kubernetes doesn't see your workload as containers, right? Kubernetes sees your workload as pods. And when you're going to be running your application, right, you will have a separate pod for front end, you will have a separate pod for back end, right? And you need to make sure that those things are talking to each other, right? So how do pods talk to each other, right? Now going into that, before going into that, I will just like to talk about that everything here is divided into based on namespaces, right? So every pod has their own pod network namespace, and every node would also have their root network namespace, right? So if you see here, that's called a root NS, right? And there would be an Ethernet device. I'm taking Ethernet 0 if you're going to be using probably newer system, you will have ENP S0, one kind of a thing, right? Now, for every pod, as I said, right, the way namespaces are divided, they give you a whole feeling of a full-fledged system, right? So every pod would also have their Ethernet 0, right? And that Ethernet 0 would be connected to a virtual Ethernet bridge, right, on the root namespace, right? So if you see in the diagram, if there is one data packet that's coming from pod one, right? So for pod one, this is their only um, only way out for a network packet, right? But this actually gets grabbed here, right? And when it's caught here, it depends on how you want to route it, right? Now, I'm just gonna take a simple example where both the pods are available on the same node, right? So there is no cross node talking here, right? So when that happens, there is usually a virtual bridge, right? That's created, and uh, when that virtual bridge sees, okay, this particular network packet is want to go to the pod that is present on the same host, right? It just gets redirected to VF1, right? Now that one of the requirement in Kubernetes networking is when a pod-to-pod communication happens, the Kubernetes doesn't want you to do a NAT operation or a network address translation operation, right? So basically, you should be able to reach it to it by calling the IP. Right? So when this packet or this pod just calls this pod's IP, the packet is gonna go here, and then it's gonna go to this particular virtual Ethernet, and then it knows that okay, this is where I'm connected to, and this is where I'm supposed to go. Right? But if packet wants to go outside of the world, so when that bridge is going to be broadcasting that okay, I've got this packet, this is the destination address, who is the guy who owns this address, nobody's gonna respond, so that bridge is basically going to send it to the default outside boundary. That's right. Now, what happens when when you want to communicate to a pod that is actually on the other node, right? It's not on the same node. So now all the pods are part of private network, right? It's almost the similar process that we saw in the previous diagram. You start from worker one, where you have the pod one. It's gonna go to Ethernet 0. It's gonna connect to the virtual Ethernet device that we have on the other end. Then there's going to be a bridge, a couple of IP tables rules, and it's gonna see that okay, the packet where it wants to go, it's not gonna be it's not on the same node, right? The destination is not on the same node, so it's going to be sending it to the default Ethernet 0 exit, and from there, now this is one of the tricky part, right? That's called a node routing table. This is something that's going to decide how your packet is going to be moving from one worker to two worker, and Kubernetes being as smart it is, it has outsourced that job, right? So Kubernetes something called a CNI. Those are container network interface, right? And you can create your plugins, and those plugins can manage that how exactly this operation is going to happen, how exactly a pod or a network packet from this pod reaches to this pod using this routing table, right? It could be anything. I mean, you can maintain this manually. You want to automate the process by keeping all the data in hand. You want to create a separate management interface for that. You want to create a separate control plane for that. That completely depends on how you implement that, right? As long as you fulfill the API requirement from Kubernetes CNI part, right? So let's just see. Right. So this is one of the example where you can implement that using IP encapsulation, right? I guess that's one of the way that Calico does it as well, right? So when your network packet basically starts from pod one, the source for it is pod one, right? But the destination is pod two, right? Because that's what the pod knows. Okay, I'm starting from here, and this IP I'm starting from, and basically this is the IP I want to reach to. But when it reaches here, right, it knows that this IP doesn't exist on that node. So it goes to this particular interface, right? From there, what we do is what IP encapsulation done is it covers that packet in with an another encapsulation or another umbrella where the source becomes the worker one and the destination becomes worker two. Now this routing, I mean, this can be routed via any of the network communication, right? I mean, because these IPs are known, pod IPs are private, but these IPs are known to the to your network connection because these are VM IPs, right? So you can talk to VM. Now, once it reaches here, once your packet reaches here, again the same thing happens. This is something called decapsulation process. You remove the outer header. Now you know, okay, this is the destination that it wants to reach, right? And so that's how the pod reaches to the client, right? Right now, okay, so this is all good, right? You can talk to pods can talk to each other. There are a lot of plugins available, and you can just make use of them based on how much control you want. You want to do like Calico by default goes on L2 layer. Cilium usually uses L3, L4, and L7 for applications, and all those kind of things, right? But one of the common concern there is pods are mortal beings, right? They can die off, and when you are scaling your applications, new pods will be coming up. Your node might go down, right? So there are a lot of things that can actually go wrong with the pod, right? And keeping a track of how many pods you have and what are their IPs and how do you want to talk them to, right? That's going to be a pretty complicated task, right? Hence, Kubernetes has a concept of services. So what services are? They're basically an encapsulation, or they're basically an abstraction on top of your pods, right? So they are a logical grouping of multiple similar entities, right? If you want to define it that way, right? So let me just take an example. You have an application and you want it to be highly available, right? Or you don't want that, if one of the pod goes down, uh, my service shouldn't be obstructed, right? So what you do is you create multiple copies of an application. That's the basic of having an high availability, right? You have multiple copies so that if anything goes down, you still have something up where you can read out your request to, right? So if you see in the diagram, we have got three backend applications, right? And then we have a front-end application, right? Now, let's say you're okay with your front-end application. You don't want to load balance it or make it highly available. It completely depends on your choice, right? Anyways, so the idea here is when you have three copies of your backend application, it's going to have three different IP, right? Now, how would you know that which IP the request should go to, or let's say one of the node goes down or one of the pod goes down? How would you know that? Okay, now I need to migrate everything over to the second application or the second pod, right? Moreover, you would also have to decide that whenever a new pod coming up, where to route that and all those things. So services provide basically an abstraction on top of that. Services have an IP and they also have domain name as well, right? So they have a full domain name, .service, .local, depending on your setup, right? So what you do is from your front end app, you just tell the service IP that okay, this is the IP I want to reach to, and then that IP is translated into any one of these pod IPs, right? We will just see in a minute who does this and how that happens. But the idea is pretty simple, right? Rather than keeping track of how many copies you have and which copy you actually want to talk to and where do you want to send your data to, what you do is you basically remember just one IP. And Kubernetes automatically makes sure that that IP, all the backend pod data is updated to the service. Service has a field called endpoints. So whatever an uh, application that's part of the backend group comes up, right? It would be just added to the services endpoint, right? And then service just load balance them in a probably in round robin way that first request goes here, second request goes to the second pod, third request goes to the third pod, and then again fourth one again moves to the first pod, right? Right. So let's talk a little about what services are, right? So as I said, they are logical grouping of pods and they are selected based on there's a field called selector, right? So when you are defining your application, be it a pod, be it a deployment, or be it anything else, you would have a field called selector, right? And as we saw in the previous diagram, selector here is app equals to front end or app equals to back end, right? Now, when you have the selector app equals to backend and you create a service and you tell that service that okay, whenever any pod that comes up or any workload that comes up with the selector app.backend, just add that to your endpoints, right? Kubernetes does it automatically for you. So you don't need to worry about even if you scale up your application or if you scale down, or if the node goes down, you would still have your request being solved, right? Excuse me. And then you also get cloud native service because, as I said, right, Kubernetes does it all on its own. Services are a native concept in Kubernetes, right? So those things happen there. And there are three ways you can define your services. One is a cluster IP. Cluster IP is basically it's an internal IP that every service gets, and this is only accessible from inside the cluster. So basically, your pods can reach out to a service using this cluster IP. Another one is node port. So when you define your service as a node port, it basically creates, basically exposes a port on every node on your cluster. Right? So let's say you've got uh, five nodes running in your cluster, and you create a service named that as a node port, type as node port, and you define the port as let's say some 32,852, something like that, right? There's a range basically 30,000 to somewhere around 37,000, something like that, right? So when you define that port as well, what you're going to do is you can just uh, type in at any nodes IP and that particular port, right? So now Kubernetes configures it for you that whenever there is a request coming in on that particular port, it gets rerouted to that service, right? And now that service is internally going to reroute that request to the particular port, right? So that's how the whole thing works. And other than that, if you want to take advantage of some more advanced configurations, you can use load balancers as well. Load balancer basically creates you want to create a GCP load balancer or an AWS load balancer kind of thing that gives you more control on the routing and the network communication part, right? You can use that as well. So this is what kube-proxy is the one who is going to do the magic behind services, right? So kube-proxy is something that runs on every node, right? And what it does is basically manages IP table routes, right? So I mean, as far as I have read about it, lot of Kubernetes networking is just IP tables magic, right? So you just keep changing rules from here to there, where the packet should come from, where it should go from, right? And kube-proxy does that for you. Right. So kube-proxy perform basically something known as DNet. That's a destination network address translation, right? So if you see in the diagram below, you will see that I start a package or a network packet from what do you call it? App equals to front end, right? And for now, it only knows that there's a service that's going to serve me backend application, right? It doesn't know the pod IP, right? It only knows the service IP. So it just says, okay, I want to go to 1.44 IP. When it reaches that service, your IP table rules are configured in a way that the destination actually gets changed, right? So when you hit that service, the packet destination gets changed to 1.23, and that's how you reach to the backend application, and then vice versa, right? Same story. Uh, Same also stands true for a node port based application, right? So in node port as well, when you reach that particular port, right, kube-proxy has configured your node's IP tables rule in a way that basically packet get routed to your service IP, and then from service IP it again gets routed to your application, right? That helps. Moving on, right? So now going one step ahead of this, right? We have talked about the containers, we have talked about how pods communicate to each other, we've also talked about if there is an abstraction that we can do, right? But what about now keeping all your applications keep talking to each other? That's not gonna that's not gonna get you users, right? If you want to talk, if you want to get customers, if you want to get your service served, right? External users should also should be able to access or talk to your application, right, inside your cluster. That's where an ingress controller comes to the picture, right? So ingress is basically something that makes sure that all your external requests are routed to the services inside the cluster, right? And Nginx is one of the widely used examples, right? You've got HFOC as well, and among others, right? Now, let's say, okay. So when your request is going to come to the Ingress controller, what you can do is you define routes, right? You can define rules that, okay, if this request wants to go to this path, please direct it to this service, right? Or if the request wants to go to this particular domain or this particular path, right? You can just go to this service, right? That way, you also create an abstraction on top of services, at least for the external users, right? Your internal application can still talk to each other, but from an external user point of view, you have got just one gateway, right? And that gateway takes care of rerouting your request to your different services inside your cluster, right? I will just see an example. So Ingress is basically a collection of routing rules, right? As we discussed, it defines or it decides how the external users can access your services that are present inside the cluster, and it also helps you save the number of public IPs. How we will see that. Right? So this is just an example of an Nginx ingress controller, right? And if you see here, basically Nginx is ingress resource, right? You have an ingress resource, right? If you see here, the domain that I actually want to look on to is foo.bar.com, right? That's where my requests are coming to. But if somebody is coming on the foo path, right? I'm just going to direct it to service one, and that's the port 4200. And if somebody is coming on the path bar, I'm just going to route it to service two. Like the way it, as you remember, we discussed in the last slide, it helps you save the number of public IPs. Now think about it. If you had to expose both of these services, right? You would have to have some way of providing them either an externally accessible IPs or probably using an external load balancer, right? Probably something AWS or GCP kind of a thing. But when you use an routing based mechanism, what you do is you basically abstract both of these services out, right? So you don't have to directly just contact them. Right? Okay, that was what I had, but this is in no way an exhaustive list of or exhaustive way of how Kubernetes communication works. There are tons of other complexities there. You have got your CNI plugins, right? As I mentioned, part about communication, Kubernetes has outsourced it and created an networking interface, right? And everybody has created their own implementation, right? You have got your Calicos, you have got Planel, you have got Cilium, you have got public cloud providers creating their own implementation of networking, right? And they work in different ways, optimized to the way that they want to make it to work, right? Or basically providing different value add on top of these, right? And that could be an whole session on each of the providers on how they work, right? Another point is that we didn't discuss is how does the DNS management happens, right? As we discussed, uh, you can reach out to services, but services have an IP. Right now, what about if you want to reach to services using a domain name kind of a thing, right? How does that happen? Just a hint, kube-proxy does that, right? But still, how exactly is that going to get routed, right? And then how do you implement network policies? How do you make sure that what kind of traffic you are allowing, what kind of traffic you are denying, and those kind of things, among other things, right? And also, sorry, this is supposed to be IPv4, IPv6 12 stack, right? So the idea is with recent, and that is a pretty recent development where you can actually have dual stack in your application, right? You want to provide a port, one IPv4 address and one IPv6 stack, right? Address, right? And I guess that feature is still alpha or either in beta. I don't think that's unstable, but still, this is something that the community is also exploring, right? Among other things. So that's all I have. Uh, I have a question from Hari. Can you show the IP tables entries for clarity? Sorry, I mean, I have a Kubernetes cluster, but that's DigitalOcean managed Kubernetes cluster. And we there in the managed services, basically you don't get access to the nodes, right? But I will make sure I add it to the slides before they go out to you guys. I will do that. Uh, Okay, I guess that's all I have. If there are no other questions, thank you for being a brilliant audience. You guys can reach out to me on LinkedIn or on Twitter. My handle there is pencil91. And let's talk about the bonus that we talked, right? So if you want to play around with Kubernetes, you want to use managed Kubernetes service, or you just want to see how Cilium works in that environment, because in DigitalOcean Kubernetes service, we use Cilium. Please feel free to go to this link, do.co//Piyush. Remember the P is capital there. And then you can just sign up. You get $300 credits. You can spin up a cluster and see it for yourself. Thank you, everybody. Thank you, guys. Bye-bye.
Thank you so much, Piyush. I got to learn a lot, and I hope that the audience has as well learned a lot. Thank you so much for the talk. And yes, for the I saw some question around sharing the slides. So we will be posting the slides on our meetup page, so you can get it from there. Also, we all of us usually hang around these Slack channels on Kubernetes Slack. So you can, if you have any questions, you can just hit us up here. You can just ask over in these Slack channels, and we will be happy to answer you. So now quickly we'll be moving to Vinod's talk. So Vinod will be talking about Antrea project. So I will be adding him to the stream. So yeah, over to you, Vinod.
Hi, cool. So could you see my screen? Hi, could you see my screen? Cool. Hope everyone could see my screen, right? Okay, cool. Yeah. So thank you, everyone. Good afternoon. So a big shout out to Prakash and Suraj, because they and each of you guys also, because this is a difficult time, and otherwise meetups we supposed to get together in a place and discuss all these technologies and doing some networking, right? But this is a totally different time, so we have to do something virtual, right? So, and in a room, when we get together for this kind of meetup, it's more interactive, but there is a limitation in a virtual session. But and not only the meetups, even the KubeCon is going to be virtual mode. So every other meetups are going to be virtual mode. There are goods and bads are there, because it will give people to without traveling to a place, you could view most of the session in a live way. Then later you are seeing in the YouTube as a recorded session. That's a good thing, but the human touch of that sessions will miss. That's the bad part. Anyway, let's move on. So today's idea is to discuss something around Project Antrea. So Project Antrea is a open source CNI project launched by VMware. Before that, who am I, right? That's your question, right? So I'm a cloud native architect with VMware. I'm with VMware for now it's almost 6 months plus. Before that, I was with Red Hat. So let me quickly move to the next slide. So we have this YouTube chat option. So if you have any queries, any doubts, any concerns, please put it in the chat, so it become we could make it interactive as possible. That's only we can do. So CNI, right? That's one of the topic for today, right? What is CNI, right? Container native, container network interface, right? Container network interface. So you might already notice that the Kubernetes is increasingly moving towards this interface model, right? You already might saw that things like CRI for container runtime interface, CSI for container storage interface, CNI for container network interface. So offloading many things from the in-tree model to outside interface model. So this will give a lot of flexibility. In a nutshell, the provider developers could independently work without waiting for the Kubernetes release, and Kubernetes releasing team also will get a lot of window without going through the build process of each of these in-tree drivers. There are chances are there bugs will go as part of the distribution. So that kind of concerns they could pretty much avoid by going with this kind of interface model, right? So that's one of the positive thing. And CSI may be a later addition, but CNI and CRI, most of you guys already familiar with. That's my that's what I'm hearing from the field. And when you look into CNI, right, that's today's topic, right? CNI is a kind of it's a simple interface. This because very limited calls between the container runtime and CNI, but once it moved to the provider side, it could be become more complex. But CNI as a interface, when you try to understand, it is pretty simple. If you go to GitHub and go through the CNI spec, if you don't have, if you are not a programmer or a Golang expert or anything, it's not required. If you are not regularly in touch with Kubernetes, build process also, you can go through the spec and pretty much you can understand what is CNI is. So what in a nutshell, what CNI is doing, like they work in Kubernetes context, because CNI is not completely for Kubernetes. CNI scope is much bigger than Kubernetes. It could work as a independent network interface for anything. It could be work as a network interface for Docker. It could work as network interface for some other container orchestration tools also. But today we are more or less focusing around Kubernetes. So basically, the Kubernetes, runtimes, it will look to the JSON config file, because that's the config file which is feeding which CNI it's supposed to use, right? And it will call that CNI with a add, right? Because once your pod is ready, you could see the pod is ready, and you have the interface, the backend interface is there. So now the next requirement, once the pod comes up in your cluster, and the next immediate requirement is there should be some mechanism to wire this pod with that backend network. That is the key requirement. Otherwise, the pod is pretty much work in its namespace, the sandboxed environment, and you cannot reach out to that containerized process, right? So it has to wire to the external interface to do some useful task with that process. So or interacting with that process. So kubectl will or kubecontrol. Your kubelet will call the CNI with a add, and based on the JSON config, it could find out that which CNI it's supposed to use, and and CNI will do the rest of the job. Like it will do the interface addition, it will do the IP allocation, all these things, because the JSON the JSON config, the JSON payload, it instruct what to do, the CNI what to do it, right? So this simple illustration could pretty much help you to understand how this workflow is happening between kubelet and CNI. So if you want to get to the step-by-step things, what is going on under the hood, right? You could see this slide, because basically the runtime create a network namespace, and the runtime reads the JSON config file, and it execute that plugin named in the config. You could be install multiple CNI plugins also. So based on the instruction it provided, right, it will call that plugin and get the jobs done. And the plugin finds out that what to do from that JSON file, and the plugin exactly do what it asked it to do, right? Once the pod or container lifetime is over, so suppose you are draining the node or deleting the pod, or whatever the changes you are making to the pod, then that interface is not required over there. So the runtime asks the CNI plugin to delete that interface. So your IP will be get back to the pool, as well as that interface also will get deleted. That's how that lib CNI to CNI plugin interaction working. So when you deploy a Kubernetes, because I assume that some of you guys went inside the kubelet configuration and saw what is the configuration specific to the CNI, right? There are two common settings required in kubelet, and one is CNI bin directory configuration, and where the binaries, the CNI binaries are available, the plugin binaries are available. That is what the CNI bin dir config config parameter is passing to kubelet. The next one is the network plugin. So you can put multiple plugin in this directory. So one fun part of the CNI is like most of these configurations will handle by the whatever the installation methods you are adopting to deploy your Kubernetes, right? That's why sometimes we totally forget about the CNI because, say for example, some of most of the kubelet installations, right? Even if you are using kube-ADM to deploy your Kubernetes also, the CNI is something like you pick some YAML files and apply it, and your CNI will comes up, right? So you might miss this kind of configuration, but in a meaningful production environment, sometimes we need to deal with this kind of parameters also. That's why I just note down over there. Then the one of the other thing I want to discuss in the meetup is like once you deploy the CNI, right? Once you deploy the Kubernetes, basically, right? When you go to the directory and see, you could immediately see some default plugins, right? So generally we refer this default plugins as reference plugins, right? You could see a lot of reference plugins in the OPT bin directory. That is the default directory for CNI plugins, CNI binaries. So if you go and see, you could see the reference plugins like Bridge, IP VLAN, Loopback, Mac VLAN, PTP, VLAN, host device. So if you look into the slide, it is, I try to put it together, right? What type of interface these plugins are creating. So most of these plugins are, actually, using the node operating system, that is nothing but Linux, right? So Linux capabilities to do some interface creation, but these reference plugins not do much complex tasks what you are expecting out of the networking provider. It do basic networking, but that is not sufficient for most of the production use cases. That's why we are depending on some third-party CNIs. So since it's a meetup, it is good to know about some of the experimental features recently added to the CNI. One experimental feature I find very interesting is like the bandwidth, right? So because when you deploy some application as a pod or a container, right? Some of the use cases we need to do some bandwidth shaping. Bandwidth shaping means some throttling enforcement about your traffic going in and out of the pod. Don't confuse with this ingress and egress wording with the Ingress API. I'm talking about the network ingress, the network traffic towards the pod, and the traffic going out of the pod, right? So if you want to do some traffic shaping, the network traffic going inside to the pod and going out, going from the towards outside from the pod, you can enable this bandwidth plugin. This is one of the experimental feature. If some of you guys are interested to play around with experimental feature of Kubernetes, the bleeding edge feature, right? This is one good thing to play around. So this kind of experimental feature, right? This is a good thing to know a lot of Linux network packet handling mechanisms, right? So if you look into that bandwidth, I don't put this slide to make you make it too complex, but I always have a tendency to go in the back end and see how this enforcement is happening. So if some of you guys are interested to know how the network bandwidth plugin it's working, right? This is how it is working, right? It is actually using the Linux traffic control capability. It's a Linux traffic control TC subsystem of Linux kernel, and it will create an additional device, intermediate functional block device, IFB, and it will apply that the bandwidth throttling requirement to that device, and there the shaping will happen, right? That's the things happening in a nutshell. So if some of you guys are interested to explore these features or learn more about the features, please go and refer this link. This is one of the bleeding edge thing. Okay, this is one of the cool thing I want to discuss. That cool thing I want to discuss today. So I assume you guys already heard about Project Antrea, right? The Project Antrea is a open source CNI project, CNI plugin project. This is mostly contributed by engineers from VMware, and there's a bigger communities happening around that project. So what is this Project Antrea, right? The Project Antrea is an open source community project advancing Kubernetes networking. It builds upon solid open source network foundation. So you could ask, you might already heard about a lot of CNIs, like Calico, like Cilium, lot of CNIs are around in the ecosystem, right? Kubernetes ecosystem. But why Project Antrea, right? Because one aspect of CNI is CNI is supposed to be very lightweight. Because the basic requirement of CNI is to wire together the pod, and you have to you want to apply some network policies around it, and and some additional features like traffic shaping, etc. That is the core requirement of a CNI. So, but from an ops standpoint, from an operational standpoint, people want to avoid the complexity of the CNI. It should not be stick out as one of the key component to manage, day in and day out. That should not happen, right? CNI is supposed to be like our hair, right? As long as you are not feeling it is there, you are good to go, right? The CNI is supposed to be like that. So that's one of the key objective of CNI. So that's why some of the data plane programming engineers, they formed this project and contributed to the community. So it's flexible and can support many types of compute. So it will work on bare metal, it will work on Linux, and currently the development is, a heavy development is happening to port it across to Windows also, because the Windows containers also slowly getting traction. So the CNI scope is extending, the Antrea CNI scope is extending to Windows also. And we have a plan to extend it beyond the community distribution of Kubernetes or certain current distribution of Kubernetes. We have a plan to extend it to AKS, EKS, OpenShift, etc., etc. So this plugin is primarily designed for Kubernetes workload, right? And the scope is more or less limited to Kubernetes. So it's built upon open source foundation, because the Open vSwitch, the Open Virtual Switch, is the core component of Project Antrea or Antrea CNI. So as I mentioned, this is purpose built for easy operation. So it should not come out as another operational concern around Kubernetes. That is not its goal. So this is a kind of slide which is trying to say about why Antrea, right? When, as I mentioned, it should be lightweight and easily available, and it should manage the Kubernetes networking and open source, right? Very easy to start with. That is one of the key value proposition of Project Antrea. So let's little bit dig deep into the technical side of Project Antrea. So K8 is in-cluster network control plane. So there is a, once you deploy Project Antrea, you get a control plane and you get a data plane, right? It supports K8's cluster networking. It depends on the overlay networking model, and it supports network policy and the service type, cluster IP type service also it will support. And it is using a lot of native K8s technologies, and that will help the project also, because the stability of the project, etc., because it is depending on lot of K8s native technologies also. Say for example, it leverages on K8s API libraries. So Antrea controller and agents are based on K8s controller and API framework. I will try to explain what that means. All components are deployed using K8s manifest. So it is a symbol. It's a symbol manifest, and you can pretty much deploy Antrea using kube control apply or kube control create command. It's pretty much easy to deploy Antrea. Leverages open source data plane. As I told, the Antrea CNI's data plane is obvious, Open Virtual Switch. So as we discussed in the previous slide, it is a multi-platform CNI. It could support virtual machine. It could support bare metal. It could support public clouds, right? Even if you have a DIY kind of model, you can deploy there also. And it is lightweight and easy to deploy. So this is the architecture view of Project Antrea. It's a kind of a slightly high level, but this illustration provides a kind of the internal details of Project Antrea. So once you deploy Project Antrea, right, it will create a subnet per node and a local IP allocation. So it will immediately distribute the CIDR you are defining for the port network to as a small CIDR to each of the nodes, and from that CIDR it will allocate the IP address to the port. That's how it is working. So it is whenever it is talking between the nodes, it depends on the overlay network. I have an illustration over here. Don't worry if you are confusing with the term overlay. So it supports cluster IP and node port service, and it supports the network policy. Network policy is nothing but, if some of you are not familiar with network policy, it is nothing but there is a Kubernetes API available to create the network policy. The objective is to control the traffic happening between the ports. Suppose you have a two-tier application. For example, you have a two-tier application, and your the web tier only talking with outside, and the database tier only talking with the app tier. Then you don't want to expose your database to outside, and more than that, you want to restrict that only your app tier port can talk with the database tier, right? And that also through some of the specified port. Say for example, if you are deploying a WordPress kind of application, right? You deploy a MySQL and you deploy a PHP app tier. So your WordPress application, WordPress app tier only supposed to talk with the MySQL using 3306 port only, and there is no other ports supposed to open from that container, right? Sometimes if you build a container, unnecessarily some other ports also might be listening, right? Especially when you are using randomly picking container from the registries. So in that case, you can use this network policy to create a host firewall kind of model, wherein you can pretty much very intuitively you can prevent that or control the traffic going in and out of that port. It's a very, very easy mechanism. So Project and lot of CNIs are supporting, but Project Antrea also support. But the key differentiation between some of the other CNIs and Project Antrea is the way the network policy is enforcing in the control plane. That is the way the network policy is enforcing in the data plane. That is the key differentiation. So I will explain how it is faring in that aspect. And there's a UI for Kubernetes. You might heard about Octane. If you are using Octane, there is a plugin for Antrea. So as I mentioned, right, how Antrea is doing the network policy, right? So Antrea is doing the network policy. When as I told, right, where the network policy is using to apply some host level kind of network restriction across the pod. Suppose you have a 25 node Kubernetes cluster, and sometimes you deploy a application. That application only having one a couple of pods, right? Maybe it's a microservice. You have 10 services, and each of the 10 services may have pod replica count of 2 or 5 or something like that. And each of the services, you have a separate requirement for a network policy. And but the thing is, like, when you applying network policy, you don't need to apply network policy across the node. You need to apply the network policy only for the pods, because network policy scope is only for the pod. So you need to apply the network policy only for the pods running on certain nodes. You don't need to apply that network policy across the nodes, across the cluster. That is a kind of network overhead, right? So you need to you need to do a target approach to apply the network policy. Wherever your pods are running corresponding to that service, there only you need to apply that particular policy. So the Antrea CNI is exactly doing like that. Whenever it is applying some network policy for a set of pods, it will enforce that policy to the wherever that pods are running. It will push that policy to that nodes only, the agents running on that nodes only. That way, you might not see that too much difference in a small cluster, but when you think about a bigger clusters like a 50 or 100 node clusters, and you are frequently updating the network policies across the services, that make a lot of difference. And the Antrea controller basically pushing these policies to the agent using protobuf. That way also the communication between the controller and the agents are optimized. And with your permission, this virtual meetup, so it's not good to go back and forth in slides, but till I want to make a point, that's why I went back to one of the slides. So in Antreas, there are two ways you can deploy. Suppose you are deploying only Antrea agents, you are pretty much good to go. Your IP allocation, the pod networking, all the things will work. The Antrea controller only will coming into picture when you want to apply network policies. So that's where the Antrea agent is pretty much capable to do all sort of IP management. The Antrea controller is only coming into picture when you applying the network policies. That's how lot of control plane, data plane kind of or master to agent kind of traffic optimized in the design, in Antrea design. So if something is happening with your Antrea controller, it is nothing to do. It is only to do with the network policy management. It is nothing to do with. So it is not blocking your traffic. So this Antrea agents will be get deployed in all the nodes of your Kubernetes cluster as a daemon set. So I think the Piyush in the previous session he already shown this slide, but in a project Antrea context, when you look into the slides, right? So it looked like this. So if you in each of your Kubernetes node, the Antrea agents will deploy a OVS bridge, and your pod will get hooked to that bridge. There is a VETH pair. It will create, and one end will hook to the pod namespace, and one end will connect it to that OVS bridge. That's how the networking is happening. So there is a gateway will create, and all your pod subnet pointing to that gateway, and there is a tunnel also will get created. So this is the simple, if you go to the simple illustration of how your pod look like after you deploying, Antrea CNI. This is how it look like. And this is a simple illustration to discuss about the traffic flow, the network traffic flow. So when your pods are talking inside the same node. Suppose you have multi-node cluster and assume you have 2 pods in node 1, and if these 2 pods are talking each other, you look at this green line. I hope you could see the green line. So it will the pod will not cross the traffic outside the node. The traffic will flow from port 1 to port 2 via the bridge. That's how the traffic is happening. Whenever internode port-to-port communication happening, so you have to follow this violet line. You could see a violet line over here. So this is how it is happening. The pod will talk with its bridge, and the bridge, there's a encapsulation will happen. Encapsulation means you might heard this term called the overlay. Overlay is a kind of tunneling mechanism, because you don't have any separate network. You don't need to do any separate network wiring between the nodes. You have to depend on the existing connectivity between the node. Via that existing connectivity, it will create a tunnel. So it's a VXLAN or GNU kind of tunnel. That tunneling mechanism is, in a simple and plain English, we can assume it's something like a tunnel creation happening in that underlying network, right? So more technical term, we call it as encapsulation. So from the port, the traffic will go to its own bridge, the bridge present in that node, and then it will encapsulate and moving over this existing underlay network between the nodes, and it will reach out to the next bridge, and it will go to the port, the destination port. That's how the internode port-to-port communication is happening. Whenever pod is talking with the outside entities, right? The traffic will flow via the OBS bridge. Then it will do a source netting, because these IPs are not reachable to outside, because once it reach outside, when that outside entity send the traffic send the traffic back, it cannot reach out here. So that's why it do a source netting to the node IP, that particular node IP, and the traffic will go outside. That's how the traffic is going out from the pod. So if you could capture, if some of you guys are new to pod networking model, if you could capture this picture, this more than sufficient to understand more or less every CNI is how it's handling, right? So how some of you are, I'm sure some of you are interested to try out Project Antrea. The only one thing you have to take into consideration is like suppose you are using kube-ADM to deploy your Kubernetes, right? So there is you might aware that there is a parameter called cluster cider you pass to kube-ADM. So you have to specify a cider range. From that cider range only it is allocating the IPs to the pod. So only one thing you have to take into account is like since Project Antrea using a node subnet model, you have to go with a slightly larger cider. Say for example, /16 or /18/20 kind of slightly larger cider, because normally we use a 10 dot series kind of cider, right? That's a default model. So a slightly larger cider you have to add. This is if you are using kube-ADM, this is the command, because otherwise if you split into multiple small IP segment to each of the nodes, immediately this cider will utilize. It will consume the available IPs in this cider, right? That should not happen. That's why I recommend you to go with a slightly larger cider and deploy it. Once you deploy, what you're supposed to do, that your Kubernetes ready, right? As a second step, you can go and apply this Antrea deployment script. Basically the Antrea manifest. You can use the kubectl apply command against that Antrea manifest. It will deploy the Antrea components in your Kubernetes environment. So it's a very, very straightforward installation. There is no complexity. It is as simple as any Kubernetes deployment model. So you can go and try it out. And one more important thing I want to mention here is like we normally talk about the observability, right? typically we leaving this network observability to as a ops concern, and we not typically talk about how the network traffic is observing, or now how the network flows happening. That we not typically talk about as a development concern or a DevOps concern. But one good thing with Project Antrea is like without doing much instrumentation, you can enable network observability in Project Antrea. So you all you need to do is you have to enable one parameter. The metrics, the Prometheus metrics endpoint, you need to enable in the configuration config map file in config map file. Once you enable the network, Prometheus endpoint, right? You can go and deploy the Prometheus. Again, another manifest available in the same repository. So this is the repository path. You can go and deploy that Prometheus. It's a complete Prometheus. It will get deployed. Once you deploy Prometheus and go back to that config config map and enable that parameter, you are good to observe your network traffic. So I think I could show some kind, a view of how it will look like, right? So I'm trying to, I create a alias for the kubectl. So if you look at here, right, so you can see the agents. I have a 2-node cluster. That's why the agent will get deployed in each of the nodes. So this agent will create your obvious bridge and everything. You don't need to install obvious bridge or anything. The agents will create it, and the controller will get created there, right? As I told, the controller main role is to apply the network policies. Otherwise, pretty much other IPAM functions will taken care by the agents itself. So once you apply the Prometheus, right? Once you apply the Prometheus manifest, it will create a Prometheus environment, a Prometheus deployment also. Suppose you are going into inside the monitoring, it will create a by default it will create a node port service for Prometheus. So this is the Prometheus service. So suppose you go back to your network. Hope you are seeing. Let me slightly more. So this was the Prometheus. So if you go to the Prometheus and see, you can see a lot of network related parameters you can watch out from here, right? Suppose you want to see how many network policies you applied, just click it, execute it. You can see that 3 network policies it applied, right? And you can generate the graphs, etc. And if you want to integrate with a Grafana or something, that also you can do, right? So this is how you get a complete network observability from this implementation. So I mentioned that you have to you have to enable something to get this Prometheus monitoring view. So let me
Vinod, can you zoom in?
okay. So you can see the config, the Antrea config map. So if you so this is the parameter I told. By default, this parameter will be false. So all you need to go and uncomment it, edit it as true. That's it. So your then you apply the Prometheus manifest file. You are good to see all your network traffic over there. So this is very interesting, and this is very easy also, right? So I may highly encourage you to go and explore Prometheus monitoring capability of project Antrea CNI. So as a matter of bonus talk, I could touch on the Multus part. I don't want to explain too much. I think we are going to the top of the time. So Multus is a meta CNI. We call it as a meta plugin, right? So what Multus is doing, like typically when you deploy your pods, it got only one network interface. But some of the specific use cases, say for example, some teleco use cases or some of the advanced use cases. Also, I saw some requirement from when you migrating your legacy application as a container to Kubernetes. They have some requirement to enable multiple network to your container, right? Multiple NIC to your container. If that kind of requirements are there, you can use Multus CNI. So what basically it is doing, it will help you to add additional network interfaces to the pod. So when you think about Multus, you have to understand that Multus itself is not a CNI. Multus is typically called as a meta CNI. So Multus will leverage on some of the CNI plugins to do its job. So you have to enable Multus, you have to create a custom resource definition. And then you have to do some some Multus configuration in your CNI config file. And once it is done, you are good to go. But this why I touch on Multus is like sometimes Multus is a very new thing. Suppose you want to have a quick glance on how Multus is working, I could probably show you this. Some of you are interested in Multus. Before concluding my talk, I could quickly show what is happening with Multus. So for example, I have an installation which is talking about Multus, and this will give a quick view what I'm trying to talk about. So you see one of the pods here. So typically pod having only one network interface. Suppose I describe this pod. Okay, describe. If you look into the description, you could see that one more additional network, right, for the pod. So this is its main IP address, and beyond that IP address, apart from that IP address, you can see one more IP address. So this IP address actually created by Multus CNI. So if you want to directly communicate with that pod, so I doing simple curl. See, it's giving an output. So I can directly reach out to that pod using the native IP address. Here I'm using a Mac VLAN plugin. As I mentioned in the beginning, there is a native plugin. So the core plugin is here. It is Antrea, and sorry, in this installation I use Calico as the primary plugin. Then I use the using Multus. I created a Mac VLAN plugin as the secondary interface for that pod. That's how it is working. So that's that the Multus is a good thing to know, because that's a kind of bonus talk. So I invite everyone to interact with the Antrea community. So you can multiple ways you can interact with the Antrea community. There is a Slack channel over here, or you can join with our Twitter channel. The team is pretty much active in Twitter. Otherwise, you can go and visit Antrea portal, right? So you can find tons of information about the project and how to deploy. All the things are there. So if you are concerned about Kubernetes deployment, or currently you are experimenting with Kubernetes deployment, or any experiments are happening in your premises, please go and give a try out to Antrea, because this is an emerging community, and as I told, this is a lightweight CNI model, and it pretty much do your job. And there are some advanced things are happening in Antrea side. One is, suppose you are deploying your Kubernetes on some of the cloud providers, right? So Antrea has a capability to do a plugin chaining. Plugin chaining means your cloud provider CNI will work as your core a network provider, and using Antrea you can enforce the network policies. So that's how you can take the benefit of both the worlds, right? You can use the Antrea controller to enforce the network policies. That's that model currently supporting in AWS, and it quickly adding to GCP and Azure also. So that's a kind of advanced level implementation, but it is worth give a try to Project Antrea. If you want to reach out to me, I'm available in LinkedIn. That's one of the main channel for me. My name is Vino Alex. So pretty much I put in the I could share while I sharing the slide. I could put my details also in the slide, and you can reach out to me also. Otherwise, I'm available in Twitter. That's it. I hope it's a give some knowledge to you around Project Antrea and Multus, right? So if you have any questions, we can quickly complete that part and move on.
Yeah, Vinod. So I think we've got like about five more minutes. So I think we can take a few questions from the comment section. So you can go through them and pick one of the questions you answer.
So one question is like, is Antrea controller also a pod in K8s? Yes, it is. It is another pod. Yes. That is right. As I told, or as I show in the screen, this is another pod in a Kubernetes cluster. Yes. What is the primary objective of Antrea project? Oh, the primary objective of Antrea project is, one is the data plane engineering capability of some of the engineers, right? To make it as a to help to make it as an open source project that will equally benefit communities. Also, as a project, its objective is to, as I mentioned, to create a more lightweight CNI. I told you a lot of operational concerns we could avoid, and as I show you, a lot of additional features, like you can quickly go and enable the network observability around observability for the CNI. So that kind of features are there. So it's a more lightweight open source CNI. That's the objective. IPAM is done by Antrea agents. Yes, IPAM is done by Antrea agents or Antrea controllers. Yes, Antrea agents. Can you please brief on the effect of CNI, say Antrea has on different kube-proxy modes? So, there is one of the new additions. It's a kind of a work in progress feature. The cluster API, we try to the Antrea community has an objective is to offload the cluster API capability to Antrea agents itself than offloading the the service implementation to IP table, because currently the kube-proxy is leveraging on IP table capability to create the services, right? You forwarding rules you are creating in the IP tables. Then one of the objective of one of the new feature, I think it is very recently. It will be part of the GA. Is the kube cluster IP based service capability to Antrea. So that will help you to avoid currently if you are thinking about a lot of performance concerns around the IP table, especially when you frequently changing the service in a larger cluster. That kind of concerns you could avoid it. So that cluster IP capability they are trying to implement in Antrea agents itself. You could follow the community and you can see that that work is happening very fast.
There were a few questions before that as well.
So one other question is like, Istio already provides traffic shaping. How is CNI feature is going to be different from Istio's one? So the simple answer is yes, Istio is doing, but Istio is not everywhere, right? Because Istio, the service mesh is not the core requirement for every Kubernetes cluster. Service mesh have its own use cases, right? Suppose your requirement is only some kind of traffic shaping enforcement in your Kubernetes cluster. You don't need to go and deploy Istio, the full Istio, right? Because Istio's objective is totally different. Just for the traffic shaping, you don't need to deploy Istio. That kind of use cases you can think about that CNI capability of traffic shaping.
I don't see any more questions over here. So
yeah,
probably we can wait.
I think I could answer all of the questions.
Yes. Oh yes, I think so. I think we can wait for 30 seconds more in case someone else has questions. In case you have questions, you can post it in the comment section. Yeah.
NSXT vs Antrea. So today's meetup is more or less the open source based meetup. So if you, I don't want to touch on NSXT because it's not open source. So but I'm happy to explain. So you can reach out to me in a separate channel.
I think that's all the questions. Yeah, I think we've come to the end of our virtual meetup today. Before we all, disconnect, I would like to thank everyone. First of all, the speakers. Thank you, Piyush. Thank you, Vinod, for presenting and taking us on a journey through the Kubernetes networking world. Thank you so much, and also thank you everyone for joining us on a weekend afternoon. After having lunch and when you're feeling drowsy. Thank you so much for joining us. I would also like to highlight a few things. Most of us hang out on the Kubernetes Slack. So this is the link, and there are a few India-specific channels that you can join. So you can find most of us online there. And if you have any questions, or if you're stuck with something, or if you generally have any questions around Kubernetes, you can just post it over there. And also stay updated with the events that are happening around India. So yeah, these are the 3 India-specific channels that you can see on your screen right now. Apart from that, yeah, you can also follow us on Twitter. We go by the tag, by the username KTSBLR. You can follow us there. You can tweet to us there. We tweet out whenever we have some events, or if we see something interesting, we tweet it over there. Also, we do theme-based meetups. So the theme of this meetup was Kubernetes networking. If there are any other themes that you would like to see in the upcoming meetups, maybe serverless, it can be observability, or any other themes that related to Kubernetes that you can think about, you can let us know, and we will try to do a theme-based meetup on that topic soon. Right? And yeah, so, and in any case, if any one of you is hiring, you can just leave that information in the comment section, or post it on the Slack channel, or yeah. We used to do this when we did in-person meetups. So at that point, we always left 1 minute at the end for people to talk if they are hiring or if they wish to get hired. That kind of networking, but I think that's not possible right now. So make use of all the channels that are available right now, and yeah. So I think that brings us to the end. Thank you so much, everyone, for joining us today. We hope to see you soon. We will be doing, the Kubernetes meetups. We'll be doing a lot more events in the coming months. So I hope to see you there. Thank you so much, everyone. Yeah. I will be ending the stream right now.